In this video from LearnElectrics, we will look at an important subject for 18th edition exams. Expect several questions on ZS and the associated calculations, which can account for up to 10% of the exam questions. We are using the Brown Wiring Regulations book, BS7671 2018, Amendment 2 to 2022. When looking at ZS numbers, many learners will ask, where do they come from? What is the start of the process? Why are there so many things to do to a ZS number? What is the 80% rule? And why is the on-site guide different to the wiring regulations book? If you can understand the reasons and the processes, if they are clear in your mind, then you will improve your knowledge and skills in preparation for your 18th edition exam. Learn how to find your way around the wiring regulations book and understand that there is a method to follow that will lead quickly and effortlessly to the right answers. We should start this video with table 41.1 on page 65. This table gives us the required disconnection times for final circuits. It tells us how quickly a protected device must react to a fault current and disconnect the supply to the circuit for different voltage ranges and earthing system types. A lot of people will flick through the book and may remember seeing table 41.1. They may even recognise the 0.4 in the middle of the table, and that's about it. To understand the importance of table 41.1, we need to go back to the opposite page to page 64. Here, we will find regulation 411.3.2.2. This regulation tells us to use table 41.1 if the circuit is a final circuit and if the rated currents do not exceed specified maximums. So, table 41.1 is only used for final circuits. Remember that nugget of information, it's important. This means that we can divide circuits into two types. Those final circuits that meet the requirements of regulation 411.3.2.2, in which case we look at table 41.1 for disconnection time information, and all the other circuits that do not meet 411.3.2.2. In these cases, we use either regulation 411.3.2.3 or regulation 411.3.2.4, as we shall see. If we look at the various symbols and words on table 41.1, what have we got? And understanding these is so useful later on. We can begin with nominal voltage. Nominal voltage is the voltage by which an installation or part of an installation is designated. Think of nominal as the name that we call the voltage. 230 volts nominal is the name, but the actual voltage when measured is often around 240 volts. For this video, we will use nominal voltages. The nominal voltage can also be shown as U0 or U0. It is a number 0, not a letter O. Calling it UO is wrong. U0 is the voltage or potential difference with reference to zero or earth potential. U is for Unterschied, and this is a German word for difference, the potential difference here to zero. Looking at some of the other symbols now, what does this mean in the red box? Look at the direction of the arrowhead. The big gap is next to U0. This is telling us that U0 is greater than 120 volts. It must be greater than, but never exactly equal to 120 volts, always greater. This symbol tells us that U0 is equal to or less than 230 volts. That U0 is not more than 230 volts. Learn to recognize these symbols. They can be the difference between passing or failing a question. Let's look at the whole thing now, the whole statement. It tells us that U0 is greater than 120 volts and equal to or less than 230 volts. So, for this voltage range, U0 can be any voltage that is above 120 volts and up to exactly 230 volts and not more. Now the earthing system. This is listed as TN or TT. TN just means either TNCS or TNS systems, since both begin with the letters T and N. TT, we should all be familiar with, systems relying on the customer's own earth rod for a connection to earth. And finally, is the voltage from an AC source or a DC source? If we know all that, we are ready to find the disconnection times. We can try a question on table 41.1. This should make things a lot clearer. The question asks, what is the maximum disconnection time for a 20 amp final circuit with a nominal voltage of 230 volts AC in a TNCS earthing system? 4 possible answers are provided. Choose the most appropriate. The answer is on the next slide, so pause the video and select your answer. The answer is C, 0.4 seconds. The question tells us that this is a 20 amp final circuit, and from the other clues in the question we know that the voltage range is in the seconds block, between 120 volts and 230 volts AC. We also know that the earthing system is TNCS, so select the row in the table for TN systems. Where the column and row coincide, we have 0.4 seconds, the required disconnection time. And if the circuit is not compliant with regulation 411.3.2.2, if it is not a final circuit, if the current ratings exceed the stated maximums, what can we do? Just below table 41.1, you will find 2 regulations that tell us the solution. Use either regulation 411.3.2.3 for TN systems or regulation 411.3.2.4 for TT systems. These regulations affect the time period for disconnection and will have an impact on the maximum permitted ZS, as we shall see. Let's have a typical exam question on these regulations. What is the maximum disconnection time for a 32 amp distribution circuit installed with a TT earthing system and the nominal voltage of 230 volts AC? All the information that you need is in the question. Pause the video and have a go. Regulation 411.3.2.4 gives us the answer, because this is a TT distribution circuit. We should choose answer A, 1 second. Now we must find the amount of current that is required to cause the breakers and fuses to trip in the required time. Go to page 417 in the Brown Book, where you will find figure 3A4. This is the response curve specific to Type B circuit breakers and RCBOs. Each device will have its own set of unique response curves. They will tell us how quickly or how slowly a protective device will operate with a certain amount of current flowing through it. More current will give a quicker disconnection time. We don't need the curves though. We are interested in the little chart at the top right. This is the time and current chart. How many amps of fault current are needed to trip the device within the specified time? Manufacturers of fuses, circuit breakers and RCBOs will make their devices match these requirements. The yellow arrow is showing us that a 10 amp Type B device will disconnect in 0.1 seconds or less with a fault current of 50 amps. We are looking for 0.4 seconds or less, so 0.1 seconds easily meets this requirement. If this was a 230 volt TN final circuit, this would be the minimum fault current required in order to respond in a 0.4 second disconnection time. Each fuse group, MCB and RCBO type will have its own charts. If you want the right answers, you must be on the right page. Take a few moments to look at the different pages and the different devices. It makes life so much easier in an exam if you are already familiar with the layout. Using the time and current chart in figure 3A4 on page 417, answer this question. What is the minimum fault current that must flow through a 32 amp Type B MCB to BS7671 if it is to achieve a 0.4 second disconnection time? You have 4 choices. Pause the video and find an answer. My choice is on the next slide. Go to figure 3A4 on page 417 and find 32 amp Type B circuit breaker in the chart. This tells us that a 32 amp breaker will respond in less than 0.4 seconds with a fault current of 160 amps. Now select your answer choice, and you should have answer C, 160 amps. We have a time, we have a current. Now we can calculate the required impedance to allow that amount of current to flow. Staying with a 32 amp Type B circuit breaker in a TN system and a 230 volt final circuit, so far we know the maximum disconnection time is 0.4 seconds. The minimum fault current required is 160 amps. What is that in terms of resistance or impedance? If we used simple Ohm's law, we would have voltage divided by current equals resistance. So, for our 32 amp breaker, that needs 160 amps to flow at 230 volts. We need to ensure that the resistance or impedance of the circuit is not more than 1.44 ohms. But this is only half the calculation. There is always a twist in the tail, something else to consider. We must make allowances for voltage fluctuations in the supply system, specifically reductions in the supply voltage. Turn to page 409 in Appendix 3. Here we will find an easy formula that is nothing more than Ohm's law plus one extra step. We will introduce an extra factor called Cmin, a minimum voltage factor. Cmin is given the value 0.95, and it will always make ZS smaller. Cmin is how we make allowances for supply voltage variations. If the supply voltage drops, then ZS will be affected. So we factor in this voltage reduction from the beginning. This is the formula. We are using the letter Z for impedance instead of the letter R. And V for voltage is now U for voltage. It's just a version of Ohm's law. Look at this as Ohm's law multiplied by Cmin. Our data from the previous calculation can be put in. Now we have 230 volts multiplied by 0.95 and then divided by 160 amps. Nothing too difficult. Our answer now is a ZS of 1.37 ohms, a little bit less than the 1.44 ohms from a moment ago. What did we do? Find the required disconnection time in table 41.1. Then, using that disconnection time, look it up in the time and current data chart in Appendix 3. This will tell us the minimum current required to operate the protective device. Now we can put the data that we have into the ZS formula on page 409. This will take into account the 0.95 Cmin factor that makes allowances for supply voltage reductions. The result is a smaller ZS, and we call this ZS tabulated. Why ZS tabulated? Because we can find examples of ZS tabulated in the tables in Part 4 of the Wiring Regulations book. Tabulated from the tables. All the popular ZS values have been calculated for you and put into tables in Part 4. This means that we do not need to make the previous calculations. The answers are all in Part 4 tables. You do, however, need to know how to do it for the 18th edition exam and for some assessments. If we look on page 68, we will find table 41.3 for circuit breakers and RCBOs on a 230 volt supply. The red box shows the already calculated ZS for a 32 amp breaker, 1.37 ohms with Cmin already applied. This is the same value that we have just calculated, and each current rating will have the ZS shown. Remember, this is a table in the regs book, ZS tabulated. Now you can attempt a calculation on finding ZS tabulated using the ZS formula. The question asks, from the tables shown for BS7671 semi-enclosed fuses, as shown here, and using the formula shown, calculate the maximum ZS value for a 30 amp fuse with a required disconnection time of 0.4 seconds. Take the nominal voltage U0 to be 230 volts AC and Cmin to be 0.95. Pause the video and attempt and answer yourself. Insert the numbers that we've been given in the question and on the chart into the ZS formula. 230 volts multiplied by 0.95 and divided by 210 amps is 1.04 ohms. We should choose answer C. How easy is that? In an exam, if you can find the right chart, you've got the right answer. Now compare that answer, 1.04 ohms, with table 41.2 on page 67. At the top of the page is the disconnection time for this table, 0.4 seconds, so we have the correct page. Towards the bottom of the table is BS7076 fuses, and the red box is highlighting a 30 amp fuse. The ZS tabulated in the table is the same as the ZS that we have just calculated. Job done. We should spend a moment or two becoming familiar with the tables so that, in an exam, we can quickly find the data that we want. What tables have we done so far? This short list tells us the main tables that we should be using, along with the page numbers in the book. You will also find these same tables listed at the very top of page 573 in the table of tables at the back of the regulations book. Learn to find this page quickly, it will save you a lot of time. There are two tables for fuses, and picking the wrong table will guarantee wrong answers in an exam. Always keep in mind that table 41.2 is for final circuits. It doesn't actually say final circuits on the table, but it does say 0.4 seconds. We have to make that connection. 0.4 seconds disconnection time means final circuits. And table 41.4 is for distribution circuits. Again, it doesn't say that in the table. Instead, it says 5 seconds disconnection time. This indicates to us a distribution circuit. Read the question, make sure that you are using the correct table. Let's have a question then. What is the maximum permitted ZS for a 230 volt distribution circuit that is protected by a 20 amp BS88-3 System C fuse? Pause the video whilst you find the correct table and select your answer. The question is about a distribution circuit. This should point you towards table 41.4 and answer C, 3.2 ohms. Be aware that exam question setters will include possible answer choices that will appear correct if you choose the wrong table. They will include final circuit answers in a distribution circuit question. Unfortunately, the wrong table and the wrong choice don't make a right answer. Now try this one. Almost the same question, but this is for a final circuit. The answer choices are exactly the same as the last question. Pause the video, use the correct table and choose your answer. You should have selected answer A, 1.93 ohms. This is the same fuse as the previous question, but a different type of circuit, and a different answer. pay attention to the tables. Table 41.3 is different. This is for BS-EN60898 circuit breakers and BS-EN61009 RCBOs. This table works for both 0.4 second and 5 second disconnection times. It works for final circuits and it works for distribution circuits. But there are 3 types of response curve to be considered: Type B, Type C, Type D. And choosing the right type is crucial to getting the right answer. A question might ask you, what is the maximum permitted ZS for a 230 volt circuit with a disconnection time of 0.4 seconds protected by a Type B 10 amp BS-EN60898 circuit breaker? The answer, of course, is 4.37 ohms. Another question might ask almost the same question, but now with a 5 second disconnection time. The answer is still 4.37 ohms. For these circuit breakers and RCBOs, the same current rating and the same type will have the same ZS. Moving on, the wiring regulations book lists the ZS tabulated values. The on-site guide lists the ZS measured values. And there is a difference, and you do need to know it. It matters in the exam and it matters on site. The same fuse with the same rating and the same conditions will have different ZS values in different books. The wiring regs book will show completely different ZS values to the on-site guide. So what is going on? This is because of a thing called the 80% rule. Measured ZS values, as found in the on-site guide, will make an allowance and adjustment for temperature changes. As the temperature of the copper conductor increases, the resistance of the conductor will also increase. But these ZS maximum figures must be correct at all temperatures up to 70 degrees Celsius. We achieve this by making ZS even smaller, so that at 70 degrees the resistance or impedance has still not exceeded the ZS maximum figures. The formula is shown on page 410 of the book. It is the same formula as shown on page 409, with the additional requirement that we must multiply the data by 0.8, as shown in the blue box. For the non-mathematical, 0.8 is the same as 80%, and ZS with the letter M signifies that this is a measured ZS value and not tabulated. The M is telling us that the 80% rule is being applied. These are the values you will be measuring against when on site, in someone's house, in a factory, and so on. So twice now we made ZS smaller. Cmin reduced ZS to make allowances for reductions in the supply voltage, and using 0.8 reduces ZS even further to allow for rises in the conductor temperature. We're trying to accommodate the worst conditions that the conductor might encounter, low voltages and high temperatures. If your ZS measurements on site meet these reduced figures at normal temperatures and without voltage reductions, then we can be confident that the circuit will still be safe when the temperature does rise and the supply voltage reduces. We can have a go now at this question. From the tables shown for BS3036 semi-enclosed fuses, and using the formula shown, calculate ZSM, the maximum measured ZS value, for a 30 amp fuse protecting a ring final circuit using 2.5 by 1.5 mm twin and earth cable, with a required disconnection time of 0.4 seconds. Take the nominal U0 to be 230 volts AC and Cmin to be 0.95. Pause the video and find your answer. All the information that we need is there. From the question, we have 230 volts and 0.95. From the table, we should have found 210 amps. Putting all these together, we have a result for ZSM. ZSM is 0.83 ohms, and you should have chosen answer D. If I measure this circuit on site and it is less than 0.83 ohms, then I'm a happy chappy. All is good. We can also apply the 80% rule directly to the ZS tabulated values shown in the wiring regulations book, without having to calculate from scratch using the ZSM formula. Let's answer this question. A 20 amp BS7871 System E fuse has a tabulated ZS as shown in the table below. What is the maximum measured ZS, ZSM, and again 4 possible choices. ZS measured is equal to 0.8 times ZS tabulated. To calculate the measured ZS value as shown in the on-site guide, just multiply the tabulated ZS figure as shown in the wiring regulations book by 0.8. Returning to the question then, let's remind ourselves. A final circuit is protected by a 20 amp BS7871 System E fuse and has a tabulated ZS value as shown in the table below. What is the maximum measured ZS? Again, pause the video and work out your answer. This is so easy to do. Find the tabulated value in the table. This is 1.68 ohms. Now multiply that by 0.8 to find your answer. So ZSM is equal to 0.8 multiplied by 1.68, an answer of 1.34 ohms. You should choose answer B. A quick review of how we found the answers. Find the required disconnection time in table 41.1. Find the time and current data in appendix 3. This will now allow us to calculate a ZS value. We should use the formula on page 409 that includes the Cmin factor of 0.95. This will give us ZS tabulated, and these values will be shown in the tables in part 4 of the book. If we now multiply the ZS tabulated by 0.8, we will have ZS measured. Use ZS tabulated in 18th edition exams unless ZS measured is specifically asked for, and use ZS measured when on site and measuring circuits. And a final reminder of where to find the tables and charts in the wiring regs book. The 18th edition exam is based around the wiring regulations book, not the on-site guide. A future video will look at ZS for reduced low voltage systems, and a video on using ZS from the on-site guide is also planned. Good luck to you all, and we hope that you've enjoyed the video, and thank you for watching. It really is appreciated. Please subscribe to our channel to get access to all of our videos, and remember to click on notify to be sure of not missing our next video. And you will find even more information, videos and help on our website at LearnElectrics.com. And don't forget that you can also type in LearnElectrics, all one word, into the YouTube search bar to go directly to our channel at any time from any computer. We are constantly adding new videos to our channel, so don't miss the next one. And once again, thank you for watching, and we hope to see you again very soon.